Hello, scholars, and welcome to Lesson 13, Session 2, on solving systems of linear equations by substitution. So last lesson, we got to look at a substitution problem where we knew that one of the variables equaled the other. And so we got to just change the variable, right? Because they were exactly the same. In this problem, in this lesson, we're going to take a look at it when it's a little more complicated than that. When we have a whole expression that we know a variable is. So let's take a look at this problem. It says the residents of a downtown apartment building are starting a rooftop garden. They will plant 4 beds of vegetables for every 1 bed of flowers, plus 5 extra beds of vegetables. They plan to plant a total of 30 garden beds. In the systems of equations shown, V is the number of vegetable beds and F is the number of flower beds. How many vegetable beds and how many flower beds will be on the rooftop garden? I think it'll be helpful for us to pause here and say, like, where did they come up with these equations? Because eventually, I'm going to want you to come up with the equations. So let's take a look at this. This is V. It is the number of vegetable beds. And so they're saying that for every vegetable bed, is going to be equal to the number of flower beds times 4, plus there's going to be 5 more extra vegetable beds. So they said if I take the number of flower beds times 4 and add 5 to it, I will get my number of vegetable beds. The second thing they did, and we get this equation all the time when we are doing systems of equations, that we just have a total number of things. We have a total of 30 garden beds, and we know that they have to either be vegetable beds or flower beds. So that's how we come up with this second equation. Now, we, of course, have 2 equations, so it's a system of equations. And we are going to use the substitution method. Now, the substitution method is really easy to use when we have a variable all by itself on one side of an equal sign. And I see that right here. Okay? So there's a lot of ways you can think through this problem. You could think through it constructively. But it's really easy to do when you have 2 equations that you can just manipulate. Because since I know that V is 4F plus 5, I can take this definition for V. This literally says V is 4F plus 5. So in this other equation, instead of writing V, I can just write what V is. And that is so helpful because if I can get this equation down to one variable only, one type of variable only, I know I can solve it because we have that 5-step process to solving any algebraic equation. So this should be pretty doable. Is if I write this second equation, but instead of writing V, I write what I know V is. So I'm going to rewrite this second equation. But instead of writing V, I'm just going to go until I see that. I am going to write this 4F plus 5. I'm going to write my plus F now equals 30. Notice the only thing I changed was instead of writing V right here, I wrote what V is. This was a definition of V. That V is 4 flower beds, 4 times the number of flower beds plus 5. So instead of writing the V, I wrote what V is. I just keep saying that over and over again because we've got to get that idea that we're just replacing it. We're just substituting what that is for some other way of writing it. Now that we've got this written, it should be quite easy to do. I've got 4 F's and 1 F on this side. Combined like terms gives me 5 F's plus 5 equals 30. I've already got a 2-step equation. I'm going to get rid of the thing that has nothing to do with F, and I get 5F equals 25. Divide by 5, divide by 5, F equals 5. Okay, so we know that there's going to be 5 flower beds on top of this rooftop. Now we've got to figure out how many vegetable plants or boxes there's going to be. Whenever you solve a system of equations, you've got to make sure that you figure out what a value for both equations. So you're always, in the end, going to take this value up to your original equations and plug it in where you see that variable. I like to plug it into this first one because I am going to get an answer out right away. You can plug it into this one as well, but then you're going to need to do just a bit of algebra to get it. But I'm going to plug it into this one, so I'm bringing this equation down, and I am going to say that V is equal to 4F, but I know what F is now. It's 5. I know what F is, so instead of writing F, I'm going to write 5 plus 5 additional. So V equals 4 times 5 is 20 plus 5. V is equal to 25. Okay, and just by plugging in some things that we knew, we were able to figure out how many of each we have. Now, one thing I like to do before I move on is this was a lot of work, and it's going to get even more complicated than this. These were really simple equations. I like to take this second equation that I didn't plug into, and I like to check. Okay, so I want to see everyone checking their work as well. And so I'm just going to plug in what I had. V, I decided was 25. Plus F, I decided was 5. And I need it to equal 30. And that's true. 25 plus 5 is 30 equals 30. That is true. If you get the same thing on both sides, you know you've done it right. You can prove it to yourself, and you can make sure without a doubt that you've done this correct, and you're going to get correct credit on this. So now let's summarize our thinking here. So let's say this. There will be 25 vegetable beds and 5 flower beds on this roof top garden. And we know that without a shadow of a doubt. We checked it. We had these helpful equations to help us figure it out. So that was just an example of one problem and how we can apply this understanding to a real life situation. Now we're going to keep practicing it. So if you have any questions about this particular problem, please let me know. But we're going to practice a lot more. So if you feel like I still don't get it, Mr. Gibbs, that's okay. We're going to keep working on it. So thanks for your hard work on this, and you should know what to work on next.